We'll clone ampicillin gene from plasmid TDL12 into cloning an expression vector PET50B+, which is very popular for expression in E. coli. So let's open PET50B+, and open its graphics map. So to make it less busy, I'll get rid of all the unique sites. Now let's open plasmid TDL12 and open its graphics map. So that's our ampicillin gene which we want to clone and express in PET50B+. I'll just get rid of all the text panes. I'll take a moment just to adjust both the graphic panes and look at the unique sites of restriction enzymes. This is PET50B+, and this is plasmid TDL12, ampicillin resistance gene from 30 to 250 base pairs. So any RE that we choose to cleave ampicillin gene should be before 30 base pairs, let's say BAMH1 at 17, and after 250 base pair, that is where the ampicillin gene ends, which is, let's say, 256, hint 3. So let's imagine we take BAMH1 and hint 3 sites to cut ampicillin gene out of plasmid TDL12. And let's see, we have these two restriction enzyme sites in the multiple cloning sequence of PET50B+. So there we have at 295 we have BAMH1 within the MCS, and up there at 249 we have hint 3. So let's see BAMH1 hint 3 in both plasmids specifically. So we'll select for particular sites, and from the drop down menu select for hint 3 and BAMH1, and from 17 to 256 we can excise ampicillin gene, and in case of PET50B+, we have BAMH1 and hint 3 in the multiple cloning sequence. So in PET50B+, expression is driven by T7 promoter through his tag, NUS tag, his tag, and then there is this multiple cloning sequence where we have BAMH1 and hint 3. That's where we plan to clone ampicillin gene for expression. So let's close both the graphic panes and open the construction window from the top panel. There we go, and we'll first select the vector fragment, and vector in our case is PET50B+ plasmid. I'll get rid of the unique sites and select BAMH1 and hint 3 from the particular sites. Now serial cloner always cuts enzyme in the clockwise direction. So BAMH1, and then we go all over the plasmid while pressing shift and then click hint 3. Press shift, don't forget that. So we have BAMH1 on the left side, hint 3 on the right side. And now we'll select the donor plasmid, which is plasmid TDL12. And again, just get rid of the unique sites and select for BAMH1 and hint 3 through the particular sites. So serial cloner always cuts in the clockwise direction. So BAMH1 and hint 3. I missed it. Here we go. So I'll first click on BAMH1 this time and then hint 3, so that I get the entire sequence out containing ampicillin. So BAMH1 on left side, hint 3 on right. Serial cloner will now align the top and the bottom fragments side by side and we'll try to ligate hint 3 with BAMH1 ends, which cannot work. Let's try ligating. It says serial cloner cannot ligate fragments in indicator order. That means we need to cut from hint 3 end first in plasmid TDL12. But that can't work because we need to cut only in the clockwise direction. That means we'll end up selecting the strand which is longer from hint 3 to BAMH1, and that won't contain gene X. We can flip the molecule by 180 degrees. So let's say this is plasmid TDL12. We'll simply flip it by 180 degrees, making its mirror image. It is as simple as turning over a page of a book. So we'll open the molecule. So remember, here we are not changing the molecule or its sequence in any way. We are just creating its mirror image. To do that, first we'll unlock the molecule. So just click on the locked thing, unlock it, and select the entire sequence. Now at the top panel, select sequence, and from the drop down menu, select anti-parallel or reverse complement. That makes the mirror image of plasmid TDL12. So let's create the graphic map. This is how it would look like. So now you can see that ampicillin resistance gene is oriented in the opposite direction. So let's save the plasmid. And this time it will be plasmid TDL12 anti-parallel. So let's open the construction window again and open the cloning vector PET50B plus, and I'll get rid of the unique sites, and from particular sites I'll choose BAMH1 and hint 3. If you remember, cutting always happens in the clockwise direction, so BAMH1 and then press shift, click on hint 3. Now you get BAMH1 on the left side, hint 3 on the right side. Now as donor plasmid, open plasmid TDL12 anti-parallel, and again the same thing. We'll get rid of the unique sites, and then from the particular sites we'll choose BAMH1 and hint 3. So remember, we flipped the plasmid this time so that we can cut with hint 3 first while going in the clockwise direction. So here we go, we see hint 3, and then in the clockwise direction we'll subsequently see BAMH1, which is hidden behind origin. So let's switch off the feature for a while. Now we can see BAMH1. So when we go in the clockwise direction, we can cut with hint 3 first and then BAMH1. This is why we flipped the plasmid. So now we have, if we'll align both the fragments side by side, and hint 3 will ligate with hint 3, right? So we push ligation and we got the successful ligation in a new construct where PET50B plus vector now contains gene from TDL12. So I'll just minimize the text pane of new construct, and now I'll compare it with the parent plasmid, which is PET50B plus. So let's open that. I'll just take a while to arrange both graphics map of parent plasmid PET50B plus and the new construct where the parent plasmid contains ampicillin resistance gene from TDL12. I'll choose BAMH1 and hint 3 sites in the parent plasmid just to look for positions, and same way in the ligation number 2, which is our new construct, BAMH1 and hint 3 from the particular sites. I forgot to click on particular sites. Okay, so now I can see that BAMH1 and hint 3. So compare the sizes first. PET50B plus 6733 base pairs and ligation number 2 6926 base pairs. Right, so there's extra base pairs are coming from the insert. 249 position we have hint 3 cut, and then BAM H1. So between hint 3 and BAM H1 we have this insert from TDL12 which contains ampicillin gene, right? So insert is in the opposite orientation, while the gene which codes for ampicillin resistance within the insert is in the right orientation with the promoter T7. So now we should save it. Now that we know it's the right construct, I'll just name it as ampicillin. It should be gene that codes for ampicillin resistance in PET50B plus. Well, now we can also do restriction, small restriction map. So we should cut the new construct ampicillin gene in PET50B plus with BAM H1 and hint 3. So with BAM H1 it is linearized. With hint 3 it gives a fragment which is 239 base pairs, right? So this is the larger fragment, and this 239 base pairs is what was cloned from DDL12, which contains this gene which codes for ampicillin resistance. This fragment should also be there in plasmid TDL12. So let's open that. TDL12, automatically it is cut by BAM H1. So this is the backbone and this is the fragment, right? So we know that